Hi, I'm Rick McCulloch from Testing Innovations Incorporated and testinginnovations.com. Please explore our website for answers to any questions related to automotive thermal shock testing by SteamJet. If you are not able to find the answers you are looking for, please contact me by email or by phone to discuss what you need. I'm the guy responsible for the 2013 changes to the ThermoShock Model 100 steam generator. These revisions were incorporated into Model 100 V2. The revisions were a result of the direct request of Jeff Christ at Ford Motor Company and Matt Carroll at General Motors. The problem at the time was that the operation and control of the Model 100 was too inconsistent and erratic. Most testing facilities were not afforded the opportunity to have very tight controls on the operation of the machine. Therefore, testing results varied widely from facility to facility, and the practicality of keeping the test in place was very much in doubt. The goals established for me at the time by the automotive approval engineers was pretty straightforward. First and foremost, do not change the test. Secondly, update controls and instrumentation. Third, provide a way for all test facilities to be able to perform the same test. 4. As much as possible, provide the ability to see more real-time data. And 5. Standardize the methodology for holding and testing the samples. Well, I was able to accomplish the goals set for me and never charged anyone anything for the development of these solutions. We have continued beyond that point, creating mobile outdoor workstations, indoor workstations, water bath stations, and reverse osmosis stations. All of these stations are produced by Testing Innovations Incorporated. All of these workstations are first-class stainless steel units, unrivaled in quality and price anywhere in the marketplace. In the process of time, we have become the only manufacturer of the thermal shock equipment. The thermal shock equipment is only sold in a kit package. We do have a few proprietary additions to the thermal shock equipment that make it unique and almost impossible to duplicate. Those additions will not be shared or revealed with anyone, so please don't bother asking. A simple overview of testing with the thermal shock machine is, first of all, you calibrate each time you turn the machine on. Secondly, you maintain the operating parameters that produced your required dynamic head pressure by doing the following. Tightly control the water flow rate at 2.7 liters per minute. Establish 5.5 psi of dynamic head pressure by adding the proper heat to the water. Control the system pressure and temperature by adjusting the fuel pressure. And finally, maintain calibration operating parameters during each and every test. Please watch the training video provided free of charge to help you understand the entire process.
Welcome to the Testing Innovations video manual. In this video, you will get to know your machine and learn about the operation process. This video applies to new and retrofitted thermal shock machines made and sold in 2013 and later. Please remember that you can pause this video at any time or skip ahead. For example, you may want to go to one of these sections that we have provided a time intercept for. Now, let's take a moment to identify and locate some of the controls. Let's get familiar with power switches, water flow controls, digital panel meters, fuel and air mixes, and the temperature and pressure sensors. Keep in mind that you can pause and review at any time. There are two on-off switches on the control panel. The left switch controls power to the water pump, while the right switch controls power to the fuel burner. These switches are referred to as the pump and burner switches, and they are located at the lower left of the control panel. The burner will not operate without the pump. The pump must always be turned on first and water flow verified visually through the end of the wand. The hour meter is located at the lower right on the control panel. The back pressure valve is referred to as the GO valve and controls the water diverted from the system into a recirculation loop. The water flow meter indicates system flow in real time and is measured by reading the largest diameter of the float. The digital panel meters are only output devices with the system temperature on the left and the system pressure on the right. The fuel burner is located below the front panel and has a fuel pressure adjustment screw indicated by the left arrow and an air mixture band shown above the right arrow. These are preset before coming to you. The air mixture band should always be full open. The temperature of the water steam mixture is monitored as it comes out of the burner coil and goes into the wand hose. The temperature is displayed in Celsius on the front panel meter. The over temperature shutdown sensor has a black wire attached to it and protects the equipment from getting too hot. It will automatically turn off power to the burner at approximately 175 degrees Celsius. The system pressure is monitored in the pumping circuit prior to entering the burner. It is essentially monitoring back pressure in PSI and is attached with the black wire to the front panel meter. The pressure sensor is located in the manifold next to the pump. The pressure relief valve is also located in this manifold. You are now ready to move on to powering up the ThermalShock steam generating equipment. We will be turning on the unit shortly. Before going any further, you'll need to stop and verify the following. Make sure that the pump switches are both in their off position. Make sure that you have made the proper water connections and the extra water supply is turned on. Confirm that the tank is filled with the selected fuel. You won't need it at this moment, but you'll need it shortly. And last, make sure that your unit is plugged into a properly grounded electrical outlet. Your ThermalShock unit should now look like the unit in the picture. The red number on the temperature display on the left is indicating current ambient temperature in Celsius. The green number is just a guideline for future reference as a rough estimate of water temperature when the burner is turned on later. The pressure meter should be showing a negligible real-time system pressure. It may be a small positive or negative number. It's just reflecting the water weight against the pressure sensor. If your unit does not closely resemble the unit in the picture, it's time to stop and review all of your connections and hookups. If that doesn't resolve the issue, then give Testing Innovations a call. If you've been successful at getting to this point, you're now ready to turn on the pump. Not the burner, just the pump. You should now visually confirm water flowing out of the end of the wand and verify the water flow rate on the front panel meter in a range between 3.7 and 4.5 liters per minute. During this 10-minute video, you will be watching the normal machine warm-up and stabilization prior to the calibration verification. Every time you use this machine, you will need to verify the calibration. This process is also known as the calibrate upon use phase. We have noticed that running the pump initially for a period of time before turning on the burner stabilizes the temperature of the incoming water. Doing this before initializing the burner leads to fewer adjustments after the warm-up and stabilization period that is being shown next. Ideally, you would like to see ground temperature water going into the machine. Just let the system run without adjusting anything for about 3 minutes. During this time, you'll notice the system temperature will increase to about 105 degrees Celsius to 110 degrees Celsius. Now, you'll begin adjusting the GO valve counterclockwise, opening the bypass loop to reduce the output flow to the 2.7 liters per minute target. You will also see the system pressure increase to about 25 psi to 30 psi. During the next period of time, you will be constantly tweaking the GO valve, turning the valve clockwise, closing down the bypass loop every 10 to 15 seconds over the next 4 minutes, in an effort to maintain the 2.7 liters per minute flow rate. At this stage, you can adjust to slightly below the target line of 2.7 liters per minute. Try adjusting a little at a time. Try adjusting a little at a time, keeping the largest diameter of the float just a hair below the 2.7 liters per minute target line on the flow meter. Over-adjusting will turn a 10-minute process into an hour-long process. Once the system has stabilized and the flow has stopped increasing, you can adjust the last little bit of flow to 2.7 liters per minute. This will be at approximately the 8 to 10 minute mark since the burner was turned on. At about 7 minutes into the machine warm-up, your adjustments will slow down to approximately every 30 to 60 seconds. At this point, try keeping the largest diameter of the float just a hair below the 2.7 liters per minute target line on the flow meter. You will also notice that the system pressure gauge will change colors from red to green at about 62 psi to let the operator know that he or she is very close to the target values. You will now notice how the machine's running parameters are stabilizing. Once the machine has stopped changing, you will notice the system temperature has stabilized at about 143 degrees Celsius. You will also see the system pressure stabilize at about 65 psi. Before running a thermal shock test, the thermal shock machine will need to be calibrated. Therefore, before turning the machine on, you will need to install the wand adapter for the dynamic head fixture. This will allow you to check the dynamic head pressure following the warm-up portion that is covered in the warming up the equipment section. You can see how the water flows through the wand with the adapter attached. This is what the water and steam output looks like after the 10-minute warm-up. Now, we are ready to verify or reset the unit calibration. You are going to very slightly open the lower ball valve. This will help to control the stability of the gauge needle. Please allow 10 to 15 seconds for the pressure gauge to stabilize. You will be recording the average value of the dynamic head pressure observed during this time. The target value for the dynamic head is 5.5 psi. It might be helpful to place an extra fine permanent mark on your gauge representing the target of 5.5 psi. If the dynamic head pressure is too low, you will be raising the fuel pressure. If the dynamic head pressure is too high, you will be lowering the fuel pressure. The fuel pressure adjustment screw is shown in this picture from the Getting to Know Your Equipment section and is directly above the left arrow. Remember to take note of pressure before making an adjustment. You may need to return to that pressure. Once you have established the 5.5 psi dynamic head pressure, you will need to record the fuel pressure, as well as the system pressure and temperature displayed on your front panel gauges. The equipment will need to maintain the system pressure and temperature in order to still be calibrated at 5.5 dynamic head pressure. We have found a variance of plus or minus 3 psi of system pressure will no longer produce a 5.5 psi dynamic head pressure. Once the dynamic head pressure has been set, it's time to remove the dynamic head fixture wand adapter and reinstall the wand foot. We are going to show you how this is accomplished on the outdoor mobile workstation so you have a better view of the entire process. Please remember to wear hand protection. You are now ready to perform an actual thermal shock test.
Now that you have finished the calibration procedure, let's step back from the picture and take a look at what you have done. You have basically just set the operating conditions that your unit uses to create the 5.5 psi of dynamic head pressure at 2.7 liters per minute of water flow. So once the dynamic head pressure gauge is removed, these operating conditions now become target values that need to be maintained throughout the entire testing session. These target values keep your machine producing the 5.5 psi of dynamic head at 2.7 liters per minute. This is the single most important facet of running a proper test. The redesign of the Model 100 has given us the Model 100 V2, which is extremely flexible. It is capable of running a wide range of dynamic head pressures and water-steam ratios, so maintaining the operating conditions that are needed to produce the 5.5 psi of dynamic head pressure at 2.7 liters per minute is extremely important. When done properly, your machine should be expected to run for hours with minor water flow rate adjustments. These minor adjustments will keep the system temperature and the system pressure in balance as well. During testing, it is critical to monitor the system pressure and the system temperature and water flow rate at least once every minute. The water flow rate affects everything, so you will want to keep that under tight control. The water flow rate is the only thing you will be adjusting as long as your unit is stable. The system pressure and the system temperature monitors only help you to know when the water flow rate is changing. These three running conditions are all tied together. When you see the pressure dropping, you will notice the water flow rate rising. You will need to lower the water flow rate. Always keep the water flow rate indicator within 1/16 of an inch of the 2.7 liters per minute target line. As long as your water flow rate is right on the 2.7 and your target values for pressure and temperature are still within tolerance, you are able to continue testing. If not, you must stop. So let's recap. On your screen you can see the system pressure, system temperature, and water flow rates that have been recorded during the calibration procedure on this particular day. These values have now become target values that need to be maintained during actual sample testing. This ensures that you will be running a valid test with 5.5 psi of dynamic head pressure at the required 2.7 liters per minute. This next section will help you understand what a normal testing session with this thermal shock equipment will be like. We're going to cover normal machine drift. Everyone who runs the Model 100 V2 will experience some drift while trying to maintain the individual target values. This is normal to the operation of the equipment. Each testing technician is able to and required to maintain the water flow rate at 2.7 liters per minute while monitoring the system pressure and temperature. Let's review why thermal-shock machines experience drift. Each time a machine is calibrated, the session will be unique, similar but unique. Different fuels require different fuel pressures at different altitudes in order to deliver the right amount of heat to the water at the required flow rate to produce the proper steam-water ratio at the correct dynamic head pressure. This water heating process will require very specific machine operating parameters to create the correct pressure and heat within the boiler tank to produce the correct dynamic head pressure for the current on-site conditions. I say current on-site conditions because the machine operating parameters change at each facility as the seasons change. You should run water through your machine with only the pump on for as long as it takes to find out what the groundwater temperature is in your area. The winter value is probably different than the summer value, so when you turn the pump switch on, you will be able to read the water temperature on the front panel temperature gauge in real time. So when you are ready to start a new testing session, do this before turning on the burner. For example, in the Detroit, Michigan area, the groundwater temperature is about 12 degrees C in the wintertime and about 18 degrees C in the summertime. At our facility, we have added this value to our calibration sheet as a value we like to monitor during each calibration. The groundwater temperature changes require a fuel pressure change of 10 to 15 psi throughout the year. If you start out calibrating with the warmer water from inside the pipes in your facility, you will definitely encounter drift shortly. At some point, the newer incoming water will be colder. If you have not established the groundwater temperature before reaching the calibration process, this may create some difficulty for you. This new condition will change the wand output. The drop in temperature of the water will likely cause the system pressure to drop. During this time, the water flow rate increases. The correction for this would be to reduce the water flow rate to 2.7 liters per minute. This adjustment, however, will cause the pressure and temperature to drop further. The best answer at this point is to raise the fuel pressure a minuscule amount, but just how much to adjust the fuel pressure will have to be learned over time with your equipment at your facility. Keep in mind the target values you are trying to maintain will drift. This drift will need to be dealt with. We have found that 1 or 2 degrees C of changing incoming water temperature will probably cause enough drift in the unit operating parameters to cause the water flow rate to rise out of tolerance. But how does a technician maintain the target values and control the fluctuations which we are calling drift? We have observed that keeping the water flow rate under tight control at the 2.7 liters per minute target line and not letting it go farther than 1/16 of an inch above or below the target line will be enough to stay in calibration as long as the temperature and pressure are pretty stable as well. Keeping the system pressure within 3 psi of the system pressure target will be enough to stay in calibration and ensure you are running a proper test as long as your water flow rate is 2.7 liters per minute. Once this process becomes familiar to you, you can make the tiny fuel pressure adjustments on the fly. However, if you think that you might be able to create a shortcut in this learning curve and start playing around with the fuel pressure before getting extremely familiar with this whole process, you will have a very long day ahead of you. During every single testing session, you will have to monitor the water flow rate, the system pressure, and the system temperature at least once every minute. The water flow rate will need to be adjusted periodically using the GO valve in order to maintain your individual target values. As a simple guideline, if the system pressure changes more than 3 psi from your calibration pressure while you are maintaining the water flow rate at 2.7, you will probably need to discontinue the test and restart the machine warm-up process or make a tiny fuel pressure adjustment. Whichever process you use will require 10 to 15 minutes to restabilize the thermal shock machine. The testing cannot continue during this period. You must wait until your individual target values have been achieved again. This will put you back at the 5.5 psi of dynamic head pressure. The fuel pressure adjustment technique is complicated and will take some time to perfect. The most reliable method of re-establishing the individual target values is to turn off the burner, let the machine cool down, and repeat the calibration procedure. Until you have many sessions under your belt, your best bet is to turn the burner off until you learn just how much of an adjustment in fuel pressure will work for you. After final assembly at the factory, every unit is put through a 100-point checklist prior to calibration. Before each machine is shipped, it goes through a calibration procedure. Now let's take a moment and put it all together. A good example of typical target values for Detroit, Michigan, using K1 kerosene indoors, has been inserted into this video as an objective reference point for you. Remember that Detroit, Michigan is approximately 630 feet above sea level with a normal annual temperature range of 0 degrees F in the winter to 90 degrees F in the summer. If you are in a similar location, the values that you see on your machine should be similar. A calibration certificate with values from Detroit, Michigan using K1 kerosene is provided with each unit and should function as a guide to performing calibrations.